Hi. Um, I'm sorry I'm not there today, so I wanted to leave you this because there's kind of a difficult concept that I wanna explore because this is part of what the College Board wants you to know about the internet. So I want to take a very concrete example here. Let's say that you want to go to HTTP. You use your browser and you open up HTTP www.cs.uio.edu slash tilde Rubin. Okay, that's my home page. Now, what exactly happens when you put that into your browser? Okay, so let's see. Okay, I want to break this into pieces. So here's the first thing that I want to say is this is a URL. Okay, and you're familiar with URLs just from using whatever browser you like. But I want to break this into some pieces. So here is the HTTP part. What it is a protocol. Okay, and protocols rule the internet, and it's actually a protocol that says how information is going to get transferred. Okay, so we're selecting a particular protocol, which is the HTTP protocol. That stands for Hypertext Transfer Protocol. Okay, then we have colon and slash slash, and the next part after that, which is right here, that is a server name. Okay, so that is quite literally the name of a web server, a computer that will respond to our request. Now, I didn't include it here because I actually don't have to, but you could say colon 80. Okay, and that colon and then the number there is actually a port number. And what the port number says is, okay, so I have a server, and that server could be listening on many different ports. And so you can be specific and say, when I talk to that server, I want to be talking to port 80. That is the normal port for HTTP. Okay, so that's why we didn't have to put it. We don't have to say colon 80 all the time. Okay, now then we have slash tilde Rubin. So this portion right here. And that is simply, I'm going to just call it a file name, although that's not entirely accurate. Okay, instead of file, I might want to use the word resource. Okay, although that's very generic. Okay, the reason we want it to be somewhat generic is because a lot of times it's just a file, but it could also be the name of a database. It could be any one of a number of things. The point is that this is entirely up to the server to interpret. Okay, so what do we have here? We have many different parts. We have one, the protocol that tells us what kind of mechanism are we using to get the web page. It could be HTTP. It could be HTTPS, which is an encrypted version of HTTP, or it could be other things like FTP, which is the file transfer protocol, or it could be let's see, SMTP to send mail. It could be, well, like I said, there's probably 1,000 different protocols. The one that we care about is HTTP for this case. Okay, so then the syntax with the URL colon slash slash, and then we have the server name. So that's our second part. Okay, we have the optional port. Okay, which is usually 80 for HTTP, 443 for HTTPS. Different services have different kind of default ports. So that's why normally we don't have to provide it. Okay, and then we have the file name or the resource name. That's part 4. Okay, all right. So let's talk about these in just a little bit of detail. So like I said, HTTP is one of our protocols. That's one that we kind of have to know. This is for web pages. Okay. Other protocols that you might want to know about are like SMTP, and what this does is it does email. Okay, that's how we send email. That is the send mail transfer protocol. Okay, actually, I take that back. It's the simple mail transfer protocol, and which I think is a twisted joke. If you ever look at the actual specs for SMTP, it is anything but simple, but that's what it's called. There's SSH. Okay, and what that does is it allows you to log into a machine and actually run commands remotely on that machine. So this is like a remote login protocol. Okay, there is FTP, which is a file transfer protocol. And as you see, there's many of these, right? I just don't want you to get the idea that the web is just HTTP. Okay, all right. Now that's part 1. So now part 2 is the server name. Okay. Okay, now here's where we need to understand something else that's going on the internet. Okay, so your web browser takes that URL, it looks at the protocol and goes, oh, okay, we're doing hypertext transfer protocol. I know what to do. I need to get the server. Okay, so where's my server? And it got the server name, which was www.csuyo.edu. Okay, so that's the server name. The problem is that that's not how we find servers on the internet. Okay, in order to be able to talk to a machine, we need to know its IP address. Okay, the IP address is really like a physical address, you know, for your house or whatever. Okay, that is actually where the that's what we know to be able to send information to, like letters. The name, on the other hand, is just whatever you want to call your house. Okay, so somehow we need to go from name to address. Okay, and there's actually a standard protocol for doing that. It's called DNS. DNS is domain name services. Okay, and so what we have is a DNS server that will take your name that you're looking for and it will return an IP address, right? So you can think of DNS kind of like this. There's a name and you send it to a DNS server and what comes out is an IP address. Okay, that is a nice kind of high level view. Okay, make sure you understand that high level view, but we need a little bit more detail than that. So the first bit of detail that I want to do is I want to talk about an IP address and exactly what that is. Okay, so this is really what we need. An IP address, it can be, I'm going to tell you that it's a 32-bit address, okay? And it is usually written like this. We have 4 bytes because 32 bits is 4 bytes, each byte being 8 bits. And we might actually write it in the form like 121 dot, oh, that's a dot there, 17.104.37. Okay, so this is what an IP address looks like. Okay, and as you can see, it is simply 4 bytes. Okay, and what that means is that each one of these numbers goes from 0 to 255. There's 4 of them, and they're separated by periods. Okay. Okay, so that's what an IP address looks like. Okay, so we give the DNS server the name, right, and it comes back with an address. Now, I want you to know that IP addresses are hierarchical. Okay, so what might happen is that IP addresses 121.17.104.24 through say 121.107.104.39. Okay, it could be that these are in the same network. Okay, and if you try to do something that's outside of that range, then it will simply go to a router and go to a different network. That's how that works. So when you talk about, well, rather when you hear people talking about local area networks, that's what they're talking about. That is a group of IP addresses that are pretty close to each other. Okay, and this gets into a lot of details. So that might actually not be a valid range for a subnetwork. I don't care, right? You don't need to know this in its full glory, right? I just want you to appreciate the fact that IP addresses are the sequence of 4 bytes and that they're in a hierarchy, so that computers that are close to each other will have IP addresses that are close to each other. Okay. One thing that I just want to mention here is that we have 32-bit addresses. That means that there are 2 to the 32 different devices that you can have. Okay, if you put in more than that, then you're going to run out of IP addresses. We're getting really close, and so because of that, we're moving to what's known as IPv6. That's IP address version 6. The ones that I'm talking about here are called IPv4. Okay, that's kind of right now is the majority of addresses are V4 addresses. IPv6 is the new, is actually the current standard, is what everybody should migrate to. And it has something like, I can't remember, I think it's 128-bit addresses, okay? So I don't think we'll ever run out of IPv6 addresses. I mean, 128 bits, that's ridiculous. Okay. All right. That's what we need to know about IP addresses. So now let's take a look at the DNS. Okay. So again, what we're doing is we're looking for www.cs.uio.edu. Okay. Now, here's the way this works. I'm going to just put a period at the end of this. Okay. And what I want you to think about it, you know, a name like this is I want to break it down into subparts. Okay. So I'm going to say that .edu is a domain, right? That's just a category, right? And then you have uio.edu. That's actually a subdomain of edu. Then there's cs.uio.edu. Again, that is a subdomain. And to be precise, I'm going to say subdomain of uio.edu. Okay. And then we have www.csuio.edu. That's actually not a subdomain because that's an actual computer, right? So that is actually the name of a machine. So the idea is that there's no machine called .edu. There's no machine called uio.edu or csuio.edu, but there is one called www.cs.uio.edu. The others are domains. And what's a domain? It's just a way to group things, right? So you might think in terms of folders and files. Okay. So the big lesson here is hierarchical. Okay. You remember that IP addresses were hierarchical as well. This is something about the internet. It is one gigantic hierarchy, and that's deliberate because that's one of the ways that it scales. Okay, so let me show you that. Let's say that I want to know what that address is. So what I'll do is I'll go to step 1. This is a server that I'm going to call the dot server. Okay, this is also called a TLD. It's a top level domain. Okay, okay. So I'm going to the dot server. That is like the absolute top of the internet. That's the entry point into the internet. You might have heard, for example, about the US giving up control of the internet. What they're talking about is that the dot server was in the US, basically controlled by the US, and it is now being handed over to the Internet Engineering Task Force. So that's what losing control of the internet has been all about. Anyway, we asked the dot server, we ask it not for this whole name, we only ask it for, do you know about edu? Okay, that's the question, edu, right? Now, the server actually knows about a few other things, like for example, it knows about edu, but it also knows about com, it knows about org, it knows about, for example, UK, which is the United Kingdom's top level domain, okay, and many others, right? And that's actually been one big fight, which is how many top-level domains should there be? And some people, for example, wanted to have .xxx for certain movies. Well, there's .tv, that's actually a country, but a lot of TV shows use it. Same goes for .mov. But anyway, what you have here is the top-level server, which actually knows about a lot of the common trailing domains in the internet, okay, like .com, .edu, and so on. Okay, all right. So it comes back and it says, yes, I actually know who is in charge of .edu. Oops, I missed the E. .edu. Okay, and so there's another server, right? So our web browser talks to the dot server and says, hey, I'm looking for an edu address, and it says, oh yeah, go over here. Now we have the .edu guy. Now what does he know about? Well, he definitely knows about uio.edu, okay, but he also knows about, say, stanford.edu and tamu.edu and a whole host of others, right? Each one of those, remember, is a subdomain. So when we come back and we ask this guy, hey, do you know about uio.edu? And he says, yes, I do. Okay. Now, after that, we go to the .uio.edu server. And we ask the question, do you know about cs.uio.edu? And the answer comes back and it says, yes, actually I know, because it does know about csuio.edu. It knows about a lot of other domains, subdomains, okay, that the university has. Now, eventually we go to the, you guessed it, the cs.uio.edu's server. Okay. By the way, all of these servers are DNS servers. I didn't emphasize that. Okay. So we asked this csuy.edu DNS server, hey, do you know about www.cs.uy.edu? And it will respond, yes, I know about that. By the way, it knows about a few others. That's a machine. And it actually knows about a lot of other machines. Like, for example, my machine is called oberon.cs.uy.edu. There's a printer somewhere, and it has a name that ends in .cs.uy.edu. Okay, so that's how it works, right? What's beautiful about this is that nobody needs to know all of the names that are on the internet. Okay, the top level server only needs to know about edu, .com, .org, .uk. Okay, then .com server actually needs to know about all the companies so that it can answer to apple.com. The .edu DNS server, which is a different DNS server, knows about the universities. It will know about tamu.edu, uyo.edu, etc. Right? And then you go to that university. It has a DNS server, and you ask that university, hey, I'm looking for the subdomain cs.uyo.edu. That's the department, computer science department. And it says, yes, I know where that is. It's over there. Then we ask the computer sciences DNS server for the name of one of its machines. So you see how that all works, right? So DNS is beautiful because it is hierarchical. It's also redundant in this sense. The UI.edu doesn't have like one DNS server. It has 4 DNS servers. So if one of them isn't talking to you, you simply talk to one of the other ones. And that's how you handle intermittent failures, for example. Okay, so now we have, we started with www.cs.uyo.edu, and now we've managed to turn that into a IP address. So let me do a lookup here, okay, so that I can tell you what the address of that is. I don't actually know, okay, but that's the beauty of it. I don't quite need to know. Okay. All right. So what it tells me is that is actually 129.72.216.15. Okay. So now we can go to that IP address and say, hey, I got a message for you. Okay. So now the HTTP protocol takes over, right? And what the HTTP protocol says is, I will open up a connection to this IP address. Okay. And I will send it. This is literally what the browser sends to the server. It says capital GET, okay, get, right? There's a few other things that it could say, but get is common. I'm going to get this web page, and so we might get. And this is where this comes in. What are we getting? /RUBEN, right? That is the name of the resource that I am requesting. Okay. All right. When that then returns, it's going to receive some HTML page. Okay. And the HTML page will have some text. Okay. It might also have some images, right? Those are not actually stored with the data that's being sent back. Instead, what we can send back is simply the name of the image. And so then we'll have more requests. For example, we might do another HTTP request, okay? So what we'll see is send, get, and this time what I want to get is /Ruben /images /Ruben .png, for example, okay? So what's happening there, it is a new request to the same server that says, I need to get this image, because in the HTML page we said, I want you to put this image here, right? So a single web page will result in many requests, okay? There could be dozens of requests in just coming from just one page, and they're all follow this HTTP protocol, okay? Okay, one last thing. I just went ahead and wrote it like this, get /Ruben and so on. The reality is that what we're really getting, right, is http://www.csuy.edu/Ruben, right? So here we have to go again, right? I see www.csuy.edu. I need an IP address. So how do I get the IP address? I go to the root server and I say, hey, I need to find edu. And then it says, oh yeah, no problems. That means you need to go to this location and ask it, oh, hi edu, I'm looking for UW, and so on, right? No, that would take way too much internet resources, right? Because for every little thing, we have to go all the way to the root and say, where's the edu server? So we don't do that. Instead, what we do is something called caching, okay? And caching is actually really interesting, right? So what we'll do is we have a question, right? Where is .edu DNS server? Okay, and so we might have to ask that thing, and we get back a reply. So what we're going to do is we're going to save the reply or the response and don't ask again. So the next time that I need something from www.csuau.edu, I don't have to go to the top level and say what's edu. I already know that. Okay. Oh, by the way, I also need to know where uio.edu is, right? So actually, let's cache that as well. Okay, I need to know where cs.ui.edu is. Sure, absolutely, let's cache that, right? If we make a question, we're going to store the answer. Okay, now how long do you want to store the answer for? Certainly not forever. Okay, if nothing else, the computer science department might move and change IP addresses, right? And so then when you look for cs.ui.edu, you would still have the old IP address and not listen to the new one. So the way that DNS solves this problem is by saying, by giving each answer, not just here's the response, but also the time to live for the response. It says, I'm pretty confident that this thing will be true for, say, another day, right? And so you save the information for a day, that's all, okay? Now, lastly, the whole point of caching is to make the system scale, okay? And the way that you're seeing the scaling is that if you and your computer, for example, you keep going to the computer science department at the University of Wyoming, then you have all those IP addresses saved. Whereas somebody, let's say somebody's a student at, say, Johns Hopkins, and they're not talking to the University of Wyoming right now, none of that information will be in their cache. So they actually do want to look at my homepage, they're going to have to go through that level of sequences. Maybe they don't have to go all the way to the top because they've been looking at Johns Hopkins, so they actually know what edu is, right? But they may have to go to edu and say, hey, where's uio, right? Because they haven't checked that, right? So it means that the only time that you actually have to go to the DNS server is when you're looking at something that's different than what you've been looking at recently, right? And that's great, because that's going to be far fewer times than if you simply went there every single request. Okay, so that's how the internet works. Okay, I wanted to give you kind of an overview of the way these protocols work together, right? That's a really important takeaway. So you see how DNS helps in translating names to IP addresses. You see how that allows URLs to have names, right? Which is much more convenient for people that are surfing the web. And you can also see how a single HTTP request might actually result in lots and lots of subsequent requests. So caching becomes really important, so we don't have to keep trying to find out where a particular server is located, and all of this is designed to scale, right? Again, look at the caching, that really helps scale. It's also designed to be fault tolerant. If one DNS server goes down, for most things you actually define up to 4 or more if you want, but 4 is pretty common, different DNS servers. So so that works really well. All right, like I said, I'm sorry I'm gone today, but I'll be back before the end of class, and I will see you then. Bye-bye.